Hello class, I am so excited that you have decided to join me for this Switched On Circuits class. I wanted to take a second here and introduce myself and just kind of give you a gist of some things we'll be using in this class. So my name is Mrs. Bliss, and this first week we do not have an experiment that we'll be doing. I will, however, be showing you some pieces that we'll be using. And these pieces, if you decided to order them, great. You'll be able to work right along with me and do some of the experiments. If not, that's no big deal. You can watch and learn just as much that way as well. So some of the pieces that I'll be using for the experiments throughout this class are right here. And basically what we will be using is this is a terminal to put batteries in. So if you can see, it has big spaces. We'll be sticking big D batteries into here, and then it has these little terminals on the back where we will be hooking wires to, and there are two of these hooked together. This is one and this is the other one. They're just glued together, so we'll be able to put 2D batteries in there. We can use both of them and connect them, or we can just use one at a time. So that is for the battery. Then we have this nice nifty little doodad, and it is for our light bulb. Our light bulb screws into there, and basically that light bulb then has a wire that goes in the bottom here, a metal strip that goes in the bottom and touches it on the side, and then it has a metal screw that's right down in where you screw the light bulb that touches the bottom. So that is for our light bulb. We have this, and this is a nice little switch, an on and off switch. Okay, and so we have two switches. We have two light bulbs. Woo! Don't want to leave that on the floor and have it get broken. So that is a light bulb. We have our battery terminals, and we also have several nice little wires here. And these ones are super nice because if you can see them right there, they have a nice little sort of alligator mouth, or almost looks like a wrench. Rather than alligator, I'll say wrench, because there are some alligator clips that you can use as well. But this one is just a nice little wrench, and it will slide right into any of these terminals, and we'll be able to screw them down so they have nice tight. So we have, let's see, I have 4 red and I have 4 black. So we'll be able to use those. I also have a screwdriver if need be. I have lots more. Let's see, 1, 2, 3, 4. I have 5 total light bulbs, and then I have another little wrench here in case we need to tighten any of our materials here. So we're all excited about this class. We'll be using some of this stuff and watching some things work, and after this we're just going to take some notes today. So I want you to make sure that you have your notes paper, your student notes paper. There's 2 that you needed printed out. So if you do not have those 2 pages printed out, I want you to press pause, get those printed out, and come back, because we're going to just jump right in to taking some notes that you'll need to know to get class started here. So you've probably watched a couple videos already and before this one, and those videos had some great information. You'll also have a couple of discussion questions after each of those videos, so I hope that you found those as well. So there's sort of a video, a short discussion question, a video, short discussion question, and then we have this video where we're going to get some notes all in one place so that we can have those handy when we need them. So go ahead, press pause, and get your notes papers printed. If you already have them printed, just stick with me here and we'll just get started, okay? So let's get started with this first notes, student notes page. And you can see there at the top it says, what is electricity? So make sure you get that one out. And as we go along here, I'd just like you to fill in the blanks as I do. And if I'm going a little bit fast, you can always either pause the video or you can come back and rewatch it. Much of this is stuff that you probably have already heard and seen from the videos, the little videos that we've watched. So let's just get started here. Electricity. What is electricity? The first one there is just a definition of electricity. Electricity, a type of energy caused by the buildup of electrons in one place or the flow of electrons from one place to another place. Okay, we've seen quite a bit about these electrons and how they can build up in one place or how they can flow from one place to another. So that is what electricity is. It's so small that we cannot see it with the naked eye at all, and it is all done within the atom. Okay, so that first one there is a type of energy caused by the buildup of electrons in one place or the flow of electrons from one place to another place. What does electricity come from? Okay. So we sort of discussed that a little bit almost in the definition of electricity. So where does electricity come from? Electricity comes from the movement of electrons from one place to another. As we said, this happens in a very, very small thing called an atom, and it is what electricity is and where it comes from. It comes from just that movement of those electrons. So I've mentioned atom a couple of times, and if you see here, I have a picture of an atom. And you can see in the middle of the atom are the protons and neutrons. And orbiting around those protons and neutrons are the electrons. So you definitely want to know what is what on that diagram there of an atom. So as we said, protons. Proton, the definition of proton is a small particle in the nucleus of the atom with a positive electrical charge. And as you can tell there in our diagram, the protons are in the middle there. They have a plus for the positive electrical charge. So go ahead and get that filled in. Proton, a small particle in the nucleus of the atom with a positive electrical charge. Next we have neutron. Okay, the definition of a neutron is a small particle in the nucleus of the atom with no electrical charge. And as we can see there in our diagram, the nucleus are blank. They don't have a plus or a minus on them. They're just those little circles or dots there in the middle that are connected to the protons and have no electrical charge. So there's nothing written in those. So go ahead and get that filled out. A small particle in the nucleus of the atom with no electrical charge. Next we have electron. And an electron is a small particle that orbits the nucleus of an atom with, I should say, an electrical charge. You can add the N in there if you want to, with an electrical charge. All right. So in our diagram, we can see those electrons that are orbiting around that nucleus that has the protons and neutrons. And the electrons are orbiting around, and they are the important thing when we are talking about electricity. So go ahead and make sure you get those 3 blanks filled in beside electron there. A small particle that orbits the nucleus of an atom with an electrical charge. Next we have the 2 types of electricity. Okay, if you remember from our videos, the 2 types of electricity are static electricity and current electricity. Let's look at the difference. Static electricity is the accumulation or buildup of excess electrons on an object. Go ahead and get those 2 blanks filled in there. The accumulation or buildup of excess electrons on an object. If you remember from our one video, there was a picture of a hand, and the hand had all of these minuses on it, and when the hand touched the metal door handle or doorknob, then several of those minuses from the hand went onto the metal doorknob, and that is an example of static electricity. That is what happens when you get shocked, when you like touch a door handle and you have static electricity and you sort of feel that little shock. So that is static electricity. Next is current electricity. The other type is current. And the definition of current electricity is the flow of electrons from one place to another. Okay, this is the kind of electricity that you use when you plug something in or when you're using a battery. That electricity is flowing. When using a battery, it's flowing from one end to the other. And when using your plugs in your house, it is flowing out of your plug through whatever it is that you are wanting to make run, and then it goes back to the plug again. So that is current electricity. Get those 3 blanks filled in. The flow of electrons from one place to another. All right, let's switch over to the second page here. There's a few more things that we talked about or we watched in our videos, and we want to get those things all in one place on our student notes here as well. So if you look at the top there, it says 3 ways we convert energy into electricity. And the first way that we convert energy into electricity is burning. Do you remember the 2 things that it was? Natural gas and coal. So that is one way that they make electricity, is through burning natural gas and coal. So go ahead and get that filled in. The next way that we convert energy into electricity is through nuclear power. And this is a picture of a nuclear power plant. So go ahead and write in the word nuclear. That is the second way that we as a society convert energy into electricity. And the third way, it's 3 for 3 kind of. The third way we convert energy into electricity actually has 3 different ways within it. Okay, the third way is using natural sources, and there are 3 different natural sources that we use to convert energy into electricity. So the first one is wind, and you may have seen windmills as you drive along some different places. A lot of times there's several of them in a row, and these fan blades on these windmills are what are making energy to convert into electricity. So the first natural source there is wind. The second natural source is solar, and these are solar panels that you see in this picture. So go ahead and fill in solar. And the last way is water, and this is a hydroelectric plant. This is what it looks like whenever they dam up water and use water in a hydroelectric plant. So those are the three natural sources: wind, solar, and water, that they use to convert energy into electricity, as well as the two other ways, through burning natural gas and coal and through nuclear power. All right. So there are a couple other things here that, definitions here that I want you to know, a couple words that I want you to be aware of, and they all come underneath this title of how is electricity measured. Okay, so the first one here is voltage, or volt. And if you look at the definition there, it says force used to move electrons causing electricity to run through a wire. Okay, so that is the voltage. That is the force of these. And if you remember the picture, if you saw those atoms and there were several atoms beside each other and the electrons were jumping from one atom to the next atom to the next atom to the next atom to the next atom, and that was the flow of electricity. And so it's the force in which these electrons are jumping from one atom to the next to the next to the next. And that is what the voltage is. So force used to move the electrons causing electricity to run through a wire. Okay, so that is what volt is. Current. Current is the steady flow of electrons. Okay, so the example we just sort of discussed of these electrons jumping from one atom to the next to the next to the next was, and the force in which it's done is voltage, but just discussing that steady flow of it moving is also called current. So these electrons moving is called current. Okay, and this current is measured in amps. Okay, so inside those parentheses out there at the end of current, it says measured in, you can fill in amps. The next word that we want to know the definition of is sort of a flip-flop with the one we just did. Amps is the units used to measure the current. Okay, so when we talk about force, it's how the force that's pushing those electrons. The current is just the basically amount of electrons going from one to the next to the next. All right. And then the definition of power when discussing electricity is the voltage and the current together, okay, is electrical power. And this is measured in watts. So the voltage and the current together is electrical power measured in watts. Okay, so it's the amount of those minus electrons going from one to the next, and it's the force at which they're going together that makes the definition of power, and they measure that in watts. So if you ever think about your light bulbs, those are watts. So these are your 2 note papers for this first week. Many of your assignments will be kind of a review of a lot of the things on these 2 note papers. So make sure you jump into Schoology here and look at all the different assignments. If you have any questions on any of the assignments, just be sure to send me a message. You can click on the little envelope in the top right-hand corner and send me a direct message if you have any questions about assignments this week. But go ahead and get that done. I can see your scores in Kahoot, and you'll be challenging the live class student as well in Kahoot. And so if there are 2 sections of this going at one time, a live section and a flex section, you'll be competing with all the students in both sections. And make sure you practice your Quizlet. Quizlet has all of these definitions that we went over. And I recommend doing 1 or 2 Quizlet games a day. And then by the end of the week, you want to send me that final test that you took Or if you get 100% before the end of the week, you can send me, take a screenshot of that and send it. Don't forget to watch the one more video that has the questions at the end as well. And if you have any other questions about any of the assignments this week, just be sure to click on that little envelope and send me a direct message. Have a good week, and I'm excited that you joined me for this class.